So maybe that file also I will upload. I think I have uploaded that file. Now you don't know the idea of system of linear equation solving. Suppose you do have two equations. Abruptly, as for example, I am writing or asking you, if I will write two equations, suppose f1 xy, that is basically e to the power x minus sin x equals to 0. This is a equation, first equation. Second equation related to two variables x and y, and that is log x plus x equals to 0. Can you able to solve this equation? These two equations are non-linear, basically transcendental. Okay, so can you able to solve x and y simultaneously for these two equations? You don't know any method till now.
No, sir.
Okay, so that type of things also you may able to implement these methods, which method till now we have learned here, that methods will be implemented. Okay, that is in your, I think you have to study in higher, or that is not in your syllabus right now, but that methods are applicable. For one general example, I am trying to giving you, and you just try to remember that recurrence scheme, that formula I am writing. It will be suppose for two equation and two unknown I am writing. It is applicable for the more equation and more unknown also, and that is the higher dimensional Newton-Raphson method also. That is not in your syllabus, but still I am giving you the idea. Suppose if you will get in your higher study somewhere, means your mind will be working such that it is solvable. Okay, if I'll ask you find a root of the complex equation, find a root of complex equation. You know root of this real equation fx equals to 0, that is we have done. We have trying to solve better approximate solution, isn't it? But what will happen if z is the complex number? What is the complex number? Then what will be the z? Can you able to solve?
No, sir.
Z is basically simultaneous of two real numbers. Z equals to here x plus iy, isn't it? Z equals to x plus iy. Bolo.
Yes, sir.
So if I'll write this equation, actually f of x plus iy equals to 0, that is actually, if I will write, I separate real part and imaginary part. In real part also it will contain function of xy, and in imaginary part also it will contain function of xy, and that is I am renaming this function is actually basically that is u plus I v. V is function of xy, that is equals to 0. When a complex expression will becoming 0, when a complex expression will becoming 0, suppose z equals to 0, when its real part and imaginary part is 0,
both are 0.
Both are 0. So this is 0 if and only if uxy equals to 0 and vxy equals to 0. Basically, you are getting here two equation, and suppose that is the first equation related to xy. This is the second equation related to xy. So basically, you have to solve these two equation. Means looks like that type of structure, isn't it? Looks like that type of structure. So basically two nonlinear, and this expression is related to x and y, but that is not linear. linear equation solving process that is in your module 2, but that is non-linear. So how you will solve this? Suppose if it is asking to you find the complex root, then how you will calculate this? How will solve this? You don't know any mathematics. You have learned some techniques that is for the single equation. Now I am telling you these equations are applicable for the system of nonlinear equations also. Means 2 equation 2 unknown, 3 equation 3 unknown, 4 equation 4 unknown. And if the expression are non-linear, then you may able to develop this method again for your higher study. So in this case, after solving this, you have to find anyhow x and y. And that will be the, after getting this, you just rearrange this, whatever the value you will get here, rearrange this in x plus iy format, that is the complex root. Is it clear?
Yes, sir. So we have to solve the F1 and F2 separately. Then
No, not separately. Actually, for the Newton-Raphson method, you know the recurrence scheme is xn plus 1 equals to xn minus f of xn by f dot xn, isn't it?
yes, sir.
For the system of nonlinear equation, suppose you do have two variables, means x and y. Then you have to write this recurrence. How I am writing this recurrence formula? You just try to remember. Suppose I do have now two equations, f1 and f2 equals to 0, and both are nonlinear. So anyhow, I have to find x and y simultaneously, isn't it? That is, I am trying to write yn plus 1. That is the column vector. In iteration scheme, it will create the vector values. Okay. And that is, I am also writing column. So how I am rearranging that formula, you just try to remember. That is equals to this, and for the single equation this is minus. In this f of xn, that places will be in vector form, or actually in matrix form. Suppose column matrix f1 xn yn f2 xn yn. That is the matrix. And how we will rearrange the derivative? Derivative will be the inverse of that matrix. Inverse of that matrix. Inverse of that matrix, can you able to write? What is the inverse? Inverse of any matrix? So suppose A inverse equals to 1 by determinant of A adjoint of A, isn't it?
Yes, sir.
So inverse of that matrix you have to write. Okay. So inverse of that matrix, if I write 1 by, means that will be above. That will be, if I will do here 1 by determinant of this, that will be above. So that value will be here. Now one will just try to write determinant of f1 xn yn, sorry, not f2 xn yn, 1 by det A and adjoint of A. Adjoint matrix of which matrix? This matrix I told you. So that is basically f of xn yn f1 f2 xn yn. So basically, if I will bring this is 1 by that value will be above. So that will be top. So your recurrence relation formula will be xn plus 1 yn plus 1 equals to xn yn minus f1 xn yn f2 xn yn, that determinant, and it's this determinant I am doing, and numerator, okay, that of f1 xn yn yn by just adjoint matrix, a adjoint matrix of this xn yn. For your understanding purpose, simply I am writing, this is not too much important, but it is important for your higher study. Okay, now you see this recurrence relation. This is the recurrence relation. So initially you may start your searching. Initially you just take x0 y0, means x0 or y0, you just take 0 0, suppose using the origin in the complex plane. You just try to search or try to do the iterations. After doing some iteration, maybe you will get some point, and that point will be the, when you will getting the matching results, you will stop your iteration, and then you will approximate your complex root also. So if you will take n0 right hand side, you will get left hand side x1 y1, that is the first iterated value. If you will get n equals to 1, whatever the value you will get in first iteration, right hand side use, you will get x2 y2. In that way, in vector way, means in pairwise x and y value will be created in every iteration. You understood this formula? Actually, my way of writing this is nothing. How from the Newton-Raphson method I have established this formula. You just try to keep your mind ready such that whenever it will be applicable in your higher study, or it will come in front of you for practical purpose, such that your mind will work, such that this is applicable, or we can able to study these things. This is not abrupt. Bolo. So all this value you may able to, after doing some iteration, you will get some value matching results. Then you will write that value approximate, x approximate and y approximate is this, and that time you will just bind up that two value as x plus iy format. That will be the complex root of the equation. Complex root of the equation. Beside, if you do have more than two equations also, suppose 3 equations, 3 unknown, and all equations are transcendental and typical nonlinear, that time one, suppose x, y, z, then z will be increased here, xn plus 1, yn plus 1, zn plus 1. So this recurrence relation is written for the in vector form for the two variables, but it is applicable for the more than two variables also. Just in the column, that variables will be increased. Okay, so using that iteration scheme, you may be able to solve this type of two equations, suppose, or more than two equations also. Is it clear? So I think module 1 is almost clear, and on the basis of module 1, whatever the conceptual parts is there, you just keep point out all that things, whatever in the classes I discuss along with you. Related to that type of question, I will ask you in quiz, and that quiz will be tomorrow. And question you will get in the quiz portion, okay? In MS Team. Any query?
No, sir.
Okay.
So we have to solve this. After this, we have to solve
These
now.
today's just try to listen again. This today's portion is not in your syllabus. What I told you now. Okay. System of nonlinear equation. How you can able to develop the Newton-Raphson method? It will be developed in this way. You can able to use this recurrence scheme for the system of nonlinear equation solving. But system of linear equation solving, that process you know mathematically also, and with the help of numerical techniques, that is we are going to discuss in module 2. System of linear equations. All equations are linear. Distance variable will be arise in the equation simply plus and minus format. There is no any power in the variables, and there is no any association in multiplication form or division form. There is no logarithmic term, trigonometric term, exponential term in the equation. Then that type of system, suppose x plus y equals to 1 and 2x plus 3y equals to 2. Can you able to solve this?
Yes, sir.
Mathematically? So
Yes,
you can
sir.
able to solve. So I think the basic idea of the linear system of linear equations you do have. 2 equation, 2 unknown, 3 equation, 3 unknown, 4 equation, 4 unknown, you may able to solve. And that idea, I think mathematically idea you do have, that is you have learned in, I think in first semester, isn't it? Besides that, you have done that is in class 10 also, 11, 12 also. Okay. So that matrix idea, mathematical idea you do have, I think. Any system, if I will write, suppose ax equals to b, when that system having solution, no solution, when infinite solution, can you able to say?
Yes.
बोलो. The theoretical background कोई बोलो, कैसा कब सिस्टम का सॉल्यूशन रहेगा, कब नहीं रहेगा, when a system will have infinite solution. Tell me. कब यूनिक सॉल्यूशन रहेगा? What was that idea of rank of the matrix and rank of the augmented matrix same, then it will have solution. But if solution exists, when it will be unique, when it will be infinite. If
Sir,
rank
we know,
of a,
but we have to recall that.
if rank of a, rank of augmented matrix is same, solution is there. If that value is equals to number of unknown, then unique solution. If that value is less than number of unknown, then infinite solution. And if rank of A or rank of augmented matrix mismatch not equal, then there is no solution. That is, you know, I think rank of A, and for that physical interpretation also, you know, rank of what is augmented matrix, that is written by A bar, augmented matrix, along with the coefficient matrix in the right hand side, B column you are adding, isn't it? If that is equals to number of unknown, means how many distant variables are there? Suppose 2 distant variable means 2, 3 distant variable 3. If it is exactly equals to number of unknown, unique solution. Otherwise, infinite solution means solution exists, unique or infinite. And if rank mismatch, rank of A and rank of augmented matrix mismatch, then no solution. There is no solution, isn't it? ये आइडिया है कि नहीं बाबू, बोलो तुम लोग का? ये सब हम मैथमेटिक्स का चीज नहीं पढ़ाएंगे अभी यहाँ. So quickly you just tell me short example I am giving you. ये सिस्टम का सॉल्यूशन है कि नहीं बोलो? ये जो सिस्टम है, x plus y equals to 1, you will get unique solution.
Yes, sir.
How we will get that unique solution? What is the process of finding that solution? Cross multiplication or Cramer's rule, like that?
Sir, we can simply just solve that.
Simply solve, and that solving procedure just cancel out or just cross multiplication,
Yes,
like that.
yes.
Okay, okay. And you have learned the Cramer's rule.
Yes,
Cramer's.
sir. We can represent these equations on in the form of matrix, like 1 1 2 3 is equal
Okay.
to 1 2.
Or during rank calculation, have you done the augmented matrix, row equivalent matrix form? In that way, you just
Yes,
reduce
yes,
your
sir.
coefficient matrix, you may get the solution also. And you will get unique solution here. If I will write a system, suppose x plus y equals to 1 and 2x plus 2y equals to 2. This is also a system, 2 equation, 2 unknown. How many solution is there here? Tell me, how many solution is there? All that things I will verify along with
Both
this
are
theory.
same, na?
Both are same, but still two equation I have written and two unknown, x and y you do have. So what will happen here?
So infinite solution exists.
Yeah, basically in this case infinite solution. Actually both equation are same, isn't it? If
Yes,
well,
sir.
so basically I do have simply one equation. So from one equation I have to write all the solutions. So its basically solution structure will be actually y equals to 1 minus x. So you just consider any x value, any x real. So in real line you may consider x up to infinite times. So y also will be infinite. So that solution structure, suppose you are considering x equals to c, then y will be 1 minus c. C is the arbitrary constant. In that way you are writing the solution structure. Okay. And if I will write equation x plus y equals to 1 and 2x, for your understanding purpose, these are very easy equations I am considering. Suppose I am writing here actually 3. Then what will happen for this system? What will happen for this system? चलो ये सब जानते हो, ये क्विकली बताओ. What if in the
So
competition
finite,
purpose? If in
finite
competition,
solution.
if it will be asked to you, what will be the solution of this system? Can you able to say what is the answer you will get? Actually, you have to give the answer logically or scientifically or actually mathematically. What you will say?
So solutions are finite.
For this case, finite. So just if solution is finite, देखो एक चीज ध्यान में रखो, एक सिस्टम का सॉल्यूशन फाइनाइट होगा मींस दैट विल बी यूनिक. मोर देन वन सॉल्यूशन है मींस इनफाइनाइट सॉल्यूशन. तो दो ही केस हो सकता है. सॉल्यूशन ट्रिवियल एक होगा, ये तो इनफाइनाइट होगा, ये तो नो सॉल्यूशन होगा. ये तीन चीज ध्यान में रखो. सॉल्यूशन अगर रहेगा तो एक सॉल्यूशन, नहीं तो इनफाइनाइट. दो सॉल्यूशन होगा मतलब इनफाइनाइट है. Linear combination of that two solution is also a solution. So in a line segment you do have infinite points. All are solution. Okay. So एक solution नहीं तो infinite solution, otherwise no solution. Three cases is there. That is clearly given to you in this theory. Okay, a little bit. So can you able to find here finite solution? How you will calculate this? How you will find this solution? You just tell me. You just simply by watching, can you able to see if I will multiply first equation by 2, it will be 2x plus 2y equals to 2. Isn't it?
Yes, sir. So the x and y will become zeros. Yeah.
Okay. And if I will watch the second equation, that is 2x plus 2y equals to 3. So from the first equation, I am getting 2x plus 2y equals to 2. And that 2x plus 2y, that is the system. Within a system, it is having. And that is equals to 3 is given. That is equals to 3 is given in this system. So basically, 2x plus 2y equals to 3, that is in the system 3. And basically that is equals to 3 from the second. So basically 2 equals to 3 is coming in this system. Is it possible? You just tell me.
No, sir. No, sir.
By watching it is clear, and that is why I am giving you this type of examples actually. Okay, so this is not possible actually. So this system having no solution. Okay, so this having unique solution, infinite solution, no solution. And let me tell you about the theory of homogeneous system. If right hand side 0, that is I will tell you little later. You just verify this theory. If I will consider for this system, what is the rank of the coefficient matrix? What is the coefficient matrix? 1, 1, 2, 3. Okay, that is the coefficient matrix. And what is the augmented matrix? Along with the coefficient matrix, right hand side you just add. So augmented matrix is 1, 1, 2, 3. Okay, sorry, 1, 1, 2, 3.
1 3.
And along with 1,
Sorry, 1
1,
2.
1, 2. And you just try to find the rank of this thing. Can you? I think you know the rank calculation of a matrix. If you will try to do row reduce echelon form of two matrix, you will get two non-zero row. And number of non-zero row will decide you how many, what is the rank of that matrix. Isn't
The
it?
rank of the matrix is 1.
Why 1? If you just try to do row echelon form, you just try to do any elementary row operation and do these things, this place 0, this place 0. Anyhow, after doing any elementary row operation, you will get two non-zero row. In this case, two non-zero row. You just do any operation. And similarly, in this case also, you will get two non-zero row. Do any elementary operation. During the rank calculation, that is you have done. So in this case, number of non-zero row will decide you the rank of the matrix. So in this case, what is happening? Rank of A equals to rank of augmented matrix equals to number of non-zero row means 2. 2 is the number of unknown. How many unknown you do have? X and Y. 2 unknown is there. So I told you rank of A and rank of A bar equals means solution is there. Then you have to check it is number of unknown equal or it is less than number of unknown. If it is equals to number of unknown, then unique solution. So number of that is equals to 2 and that is equals to number of unknown. Means what is wanting actually X, Y is unknown values. So you do have unique solution, that idea. That case, unique solution case. Number of unknown equal. Okay. And in this case, if I do rank of A, what is the in this case rank of A? If I'll write for this system, what is the coefficient matrix? A equals to 1, 1, 2, 2. If I do one elementary operation, simply one elementary. I am doing elementary new R2 equals to old R2 minus 2R1. This elementary row operation, if I'll do perform, it will be A will be equivalent to row equivalent to 1 1 0 0. How many non-zero row is there?
1.
So rank is 1. If I'll calculate augmented matrix, then again 1 and 2 will be added. In this case also rank will be 1. So rank of A, rank of augmented matrix is same. Solution exists. Then I will check what is that value. That value is less than 1. Less than number of unknown. Number of unknown is 2. So you do have infinite solution process here. Theory is verified.
Yes, sir.
You just see and watch for this last system. Rank of the coefficient matrix is 1 1 2 2. Its rank, if you will do elementary row operation R2 minus 2 R1, it will be 1 1 0 0. So coefficient matrix का rank 1 है. How many non-zero row is here?
1.
1. So rank of the coefficient matrix is 1. Now if I do augmented matrix means 1 1 2 2 1 3. Whatever the elementary row operation I will do perform here, its rank will be 2. Rank of A bar will be 2, and here rank of A equals to 1. So it is mismatch, so no solution case. No solution case means this type of abrupt thing will happen. 2 is not equals to 3. Otherwise, and when to do this, rank of A and rank of augmented matrix equals to number of unknown, that will happen simply coefficient matrix non-singular. If original coefficient matrix, its determinant value not equals to 0 means non-singular, then obviously first case will arise. Rank of A bar equals to number of unknown. Then obviously you will get unique solution. Then Cramer's rule exists. You may able to do the cross calculation and you will get the result. Okay, these are the things you have done. Actually, you have done for the 3 system or 4 system, means 3 equation, 4 equation also. But nicely you just verify this theory. What is you have learned. With the now I think scientifically you may give the answer of this. If I'll ask you in competition purpose, what is the solution of this? You will say no solution. And then if I will ask you why no solution, then what you will give the answer?
So we will verify it by rank method.
Okay, if I'll do the cross calculation, laborious answer is this. If I'll do the cross calculation, it is coming basically no solution. Its physical interpretation is this: 2 is not equals to 3. That is not possible.
Yes.
And that is mathematically coming because of rank of A is not equals to rank of A bar. Now another little bit question I am asking you. Homogeneous system, do you know right hand side 0? X equals to 0, right hand side 0. All that things, homogeneous system having always solution. That is you know. बोलो. होमोजेनियस सिस्टम का हमेशा सॉल्यूशन है. बेसिकली इन होमोजेनियस सिस्टम दिस केस विल नॉट हैपन. व्हाई? मींस सिंपली यूनिक सॉल्यूशन और इनफाइनाइट सॉल्यूशन. और दूसरी बात, अगर यूनिक सॉल्यूशन है, दैट सॉल्यूशन इज नथिंग बट 0 0 0. That is known as trivial solution. You can able to express this idea. You can able to express this idea simply. If I'll try to calculate, you just try to calculate the rank of A, that is always will be equals to rank of A bar. मीन्स जो भी मैट्रिक्स है उसका साथ राइट हैंड साइड में 0 अगर ऐड करेंगे तो रैंक क्या है एक्चुअली एलिमेंटरी रो ऑपरेशन करने के बाद नॉन जीरो रो विल टेल यू द नंबर ऑफ रैंक but 0 adding at the right hand side will not hamper the rank calculation of the coefficient matrix. Basically rank calculate rank देखने के लिए हमको नॉन जीरो रो देखना है बट 0 ऐड कर रहे हैं तो 0 ऐड में रैंक कैलकुलेशन में कोई हैम्पर नहीं होगा. Isn't it?
Yes, sir.
So this case always happen. Always happen. Okay. These type of things always happen. क्योंकि राइट हैंड साइड 0 है. कोई भी देखो कोई भी राइट हैंड साइड कोई भी कोएफिशिएंट मैट्रिक्स का साथ सपोज इसके साथ हम 0 ऐड कर देंगे तो कोएफिशिएंट मैट्रिक्स का रैंक 1 था तो इसका भी रैंक 1 ही होगा. Isn't it? 0 adding at the right hand side will not hamper the rank calculation because we are counting for the rank how many non-zero row is there, but we are adding 0 row, so 0 adding is not hampering the rank calculation. Is it clear?
Yes.
So you may write any system. Suppose now you can, if the coefficient matrix of this is equals to number of unknown, numbers of unknown means जितना variables है, then you have trivial solution imply unique, and that unique for the homogeneous system is 0 solution or trivial. Otherwise infinite solution. So any system, if I will ask you, suppose 2x plus 3y equals to 0 and x plus y equals to 0 again. What is the solution? Homogeneous system, हमेशा solution है. And to see the trivial solution, unique solution, you just seek the coefficient matrix determinant value. If coefficient matrix determinant value not equals to 0, then this case is equals to number of unknown. Rank of A equals to rank of A bar equals to number of unknown. Coefficient matrix का determinant value देखो 2 minus 3, that is not equals to 0, so its rank is 2. Rank of A bar is 2 and that is equals to 2, number of unknown. So it will have unique solution and that solution is nothing but x equals to 0, y equals to 0. That is the trivial case. Homogeneous system. Okay. And if I'll write 2x plus 2y equals to 0 and x plus y equals to 0, what will be the solution? In this case also rank of coefficient matrix, rank of augmented matrix same, but that is less than numbers of unknown. In this case rank of the coefficient matrix 1, augmented matrix 1, but that is less than number of unknown here 2, so you do have infinite solution. That infinite solution you will write, suppose y equals to 1 y equals to minus x. So you may consider x infinitely many times, you will get y infinitely many. So whatever the x value you just consider, you just take minus of that value, that is the y, and you will get simultaneously these two equations will satisfy. So you do have infinite solution. Okay, this mathematics is basically, I think you are good students. That is why I have verified along with you. But we do have system of linear equations here with the help of numerical techniques also. With actually mathematics is taking too much computational time. So with the less computation, we may able to calculate with the help of numerical techniques also. For that purpose, we do have some exact method. It will give you the exact solution and some iteration methods. Okay, that methods we will study in module 2. Okay, clear?
Sir. Yes, sir.
So this portion of discussion is today's discussion is totally out of syllabus, but all are very important for your understanding. Okay, tomorrow we will start the system of linear equation solving with the help of numerical techniques. You just before that you just try to give the quiz of module 1. Just try to study the conceptual parts all.
Okay, sir.
Bolo, any query?
No.
तो सिस्टम ऑफ लिनियर इक्वेशन का थियोरेटिकल आइडिया क्लियर हो गया? तुम लोग यही इस टाइप का ही पढ़े थे ना, दूसरा टाइप का पढ़े हो?
सर इसी टाइप का पढ़े सर।
नो सर,
मतलब
क्या पढ़े हो?
रिवीजन थोड़ा करना।
यस सर, रिवीजन थोड़ा करना।
ये सब आइडिया था कि नहीं बोलो?
हाँ सर,
यस सर था।
रैंक वैंक निकाल के
जो हम बता दिए इसमें फायदा हुआ कि नहीं? रिकॉल हो गया तो अच्छा हुआ ना?
यस सर।
वेरी गुड. So today we are ending the class. Okay.
Okay,
Thank you, sir.
Thank you, sir.
Okay, you are welcome.